Hi Twitch, how's it going? This is going to be a Chill Maths live stream where just for an hour or so I'm going to talk about some maths. See if we can do that. I imagine if you've joined, there's two reasons. Maybe you want to see some Chill Maths, or maybe you've come because of my day job, which is about the maths admissions test. Those potatoes first again. That is 2 for 2. quickest in chat. Very good. I was saying, sorry, there are two reasons you might be here. You might be here to see me mess around with some maths in that way that I sometimes do, or you might be here to hope that I say something about maths. And if you come for the second reason, then I think I'm going to disappoint you, because obviously the department is talking a lot about maths. I've been doing quite a lot of work this weekend, but it would probably not be fair for me to say stuff about the maths on a private, separate Twitch channel. The idea of this is that it's separate from my day job. So this is sort of no stress, right? It means that if you're worried that people who watch the Chill Maths might get some sort of insider information, then nah. Just want to talk about differential equations. Broadly speaking, let's do this. It's slightly banned. I've now got the ability to ban words. I thought about banning it before I went live, but I thought that'd be a bit too unfunny. Broadly speaking, yeah, sure. Yeah. Broadly speaking, I understand this was a total nightmare for absolutely everybody on Thursday. Some people were in the exam room for up to 5 hours. Some people were shown some questions, they were taken away, shown some more questions, they were taken away. Some people were in the same rooms with other people. And it was a nightmare for everyone. Sorry, I'm laughing at chat, not what I'm saying. Nightmare for everyone on Thursday. My plan overall is that it's a nightmare for Oxford now. We didn't want that to happen, obviously. It's a nightmare for Oxford, which we will work out. And we haven't made any ambitious decisions yet. So we have got, from our point of view in our admissions process, we have got time to make things right. We're going to work out how to do that properly. Yeah, toast potatoes in 4.5 hours. I am not allowed to comment on Alfie. Hi, Alfie. I'm not allowed to comment on alleged leaks, except to say that the university is aware of allegations and ongoing investigation. But I am not allowed to comment further. My big picture there is supposed to be nightmare exam situation for you, continuing nightmare for me, but I hope not a continuing nightmare for you. I hope you have been allowed out of the exam room now and that you're not joining the live stream. Still in the damn thing. 4.5 hours, sad robot. Yeah, cool. Okay. Kind of don't really want to talk about the mat, if that's all right. Everyone seemed to get offers from Warwick on the same day, and also York I just heard as well, and Al Rood kind of Harvard or whatever. So just kind of put So the thing is that everyone's very cross with Oxford. Yeah, I'm not allowed to say the next bit. Yeah. Ongoing legal reasons I've been asked not to comment too much. Yeah. I should say, by the way, in case anyone's watching, chat's not actually got a profanity filter on these words. I think that would look really bad on me. I personally find it absolutely hilarious when people censor the other university's name. Good, cool. Okay. Right. Thought about doing that more subtly. Just doing a whole live stream about the cross product. But no. My plan for today... Is it that way around? The rebels went to set up Cambridge? Some people did a murder and then went and set up the other place? Yeah, can we do the differential equations? Cool, yeah, I'm going to lose viewers because I noticed I have gained loads of followers since maths and possibly loads of viewers, and oh my goodness. I've also become Twitch affiliate, which is very exciting. I think I'm the first person to become Twitch affiliate on the back of... Well, no, I hit Twitch affiliate before... God, this is my villain era, isn't it? Thanks for the follow. I've entered my villain era. I didn't want to. Didn't mean to. Oh, yeah. I think I have to do a disclaimer as well. Yes, no, remember, this is the good news. This is the thing I was excited about before the Matt. I did a live stream last week. Hit Twitch affiliate. I'm a Twitch affiliate now. I find that absolutely hilarious. I think that's the funniest thing. I just do maths on Twitch and YouTube, and now there's like ability to do bits and stuff. It's hilarious to me. It needs to be really clear that if this thing hits, if this stream accidentally makes money, so if Toast Potatoes, I think, I don't understand. I think bits are somehow some sort of currency. If the channel ever makes money, then I will donate the money to charity, and I think I'm going to match it as well. I'm trying to figure out how to put this in like a banner on the Twitch channel to make it clear that this Twitch channel is sort of permanently in charity fundraiser mode. So that if it I've done all the Twitch affiliate stuff as a kind of joke. If it makes money, then that's not for me. That is going to charity, and I think it's getting matched. But I need to put that officially on the stream somewhere. I also get to make some emotes. I get to do emotes. Oh, it's dangerous because matching it is going to be a lot of money. So it's Twitch Potatoes. So Twitch subscriptions work like this, chat. If you subscribe, I have no idea what happens. You have the option to subscribe using some of your actual money, which I think would be a actually terrible thing to do. Don't do that. If you subscribe using Amazon Prime, I don't really understand any of this. If you have Amazon Prime and you get a free Twitch subscription or something, if you use it on this channel, then I think that's hilarious because that's giving Jeff Bezos' money to charity. There's a kind of a fine line, right, between funny pretending to be a Twitch streamer versus, oh no, it's gone too weird. There's Alfie. Alfie knocking out the park. There we go. It's a fundraiser. I am not allowed to comment on how much money Oxford has already spent on third-party contracts. It's several Twitch subscriptions. Right, okay. I've got a different equation on board. You might have seen it already. And I mean that I've been talking away for the last 5 minutes or whatever, but you might have seen this in your life before. If you've studied second-order differential equations with constant coefficients, which is what this is an example of. Don't worry about any of that. That's what it might have been called in the classroom. But I think in A-level it's something that's taught often right at the end of the... Oh my goodness. Something that's taught right at the end of A-level, and usually quite in a hurry. So I thought we'd do it slowly. Toast Potatoes has got an advert. Do let me know about adverts. I don't understand those either. I don't know if it means you miss maths content. That would be past the line of funny, not funny. Potatoes can't hear me. Just talking to Potatoes, don't mind me. Causes you to miss content that would not be funny. Oh, I get a lost star on my name now. What's the star for? I'm a 1 month subscriber. I'm sorry. Right, good, okay. Excellent stuff. I'm my own biggest fan. Yeah. So integrating both sides is something you might have seen. You might have seen dy by dx equals x squared, where you apply, integration is opposite of differentiation, and you go and integrate both sides with respect to x. So you go and integrate both sides and you say, that's y that's been differentiated, and on the right it's something like this that's been differentiated. You can solve it like that. Yeah, it causes you to miss content, okay. And we'll find out if I can switch that off after the stream, because I don't believe in fiddling with settings. Good, I am losing viewers now I've started talking about maths. That's exactly how it should be. Good. This one's harder because this y in here, we don't know what that is. there's a dy by dx. I don't know what that is. Like, we've got kind of three unknown things that are all related. So there's something else going on here. And I thought it might be fun to do a version of what we did last week. Hi, Percival. Welcome to chat. I thought it might be fun to do a version of what we did last week, where we just kind of mess around and try plugging in functions to see if we can guess a solution. Obviously, not very rigorous and routine, but try guessing. And this might give us a feel for why this differential equation is hard, or why solving stuff like this is difficult. So, people who've seen this in school or something, or if you remember this from university, then let's not give the game away too fast. So chill streams, chill. Y equals 0 is a solution. Fantastic, yeah. If y equals 0, then dy by dx is 0, and the second derivative is also 0. So if y is 0 as a function, it's a function of x, then the derivative is exactly 0, and so is the second derivative. Thanks, Larude. So then all three terms would be 0, and it would be fine. Good, okay. That maybe makes you think, are there any other numbers that work? Constant function. So this looks promising as well, because the derivative would be 0 and the second derivative would be 0. So that simplifies things quite a lot, and we would just need 2c to be equal to 0. Oh. Yes, we need some terms to be negative, correct. So maybe that's a bit of a clue as to what sort of things we're going to end up with. It can't just be a function that's positive and increasing and second positive derivative. Although saying it like that feels very complicated because, my goodness, I don't want to think about it geometrically, right? Maybe if it's got positive value, no, now the hit immediately starts thinking about it geometrically. Maybe it's over here and it's got some negative value, but it's got positive second derivative and it all balances out. It's quite hard to think about. Yeah, so next attempt that I was hoping somebody would say, and Toasty Potatoes has come through with a quadratic. Let's put this lined up over here. If y equals polynomial, and now you've suggested a quadratic. So if y equals x squared, then this is going to turn into a quadratic equation, isn't it? If y equals x squared, say, then that's an x squared over here. This term would be 6x because the derivative would be 2x and then it's multiplied by 3, and then the second derivative would be 2 or something. So that's a quadratic, but I probably want this to be true for all x. Good night, Quintix. Yeah. Percival's got a very good suggestion about how this resembles a quadratic, and if you squint, it really does, right? I will come back to your second statement, but if you squint, it kind of looks like thing squared, 3 times thing, and 2y. Of course, this term here is not it's not the same thing as dy by dx squared. You don't mean that in chat. You don't mean that. That's fine. I'm just pointing out that these things are different. This is the second derivative, not the square of the first derivative. But yeah, okay, something might happen, and there's a way to rewrite maybe a related quadratic equation. Down here for Toasty Potatoes, this is a quadratic which we could try and solve, but that'll tell us that the differential equation only holds for just a couple of isolated values of x, the roots of that quadratic, which is kind of like not what we want. Yeah, so Larude's got, yeah, and Potatoes agrees there's a problem here, which is if you do a polynomial, then you have some degree of the polynomial here and then a lower degree over here generally, and then a lower degree again. I'm saying generally because y equals 0 is kind of a polynomial. Yeah, and this particular one doesn't even have any real roots. So it's not even true for any real values of x. Excuse me. So So if you want both of these sides to match up for all x, then the polynomial you get on the left would have to vanish. It would have to be 0, which it can't do for reasons of degree. Yeah, we should stay away from weirder functions. So this is quite dispiriting, really. We found one solution that works. We tried to find more general solutions, but it kept coming back down to 0. So it keeps coming back to say, oh dear, you tried doing some stuff, but it looks like 0. So maybe just 0. That's not the actual answer, though. Let's clear a little bit of space. So our guesswork didn't quite get us there. We saw that 0 was a solution, but there are in fact more solutions. We're going to try one more bit of guesswork, I think. We kind of need these terms to balance. Yes, so trig functions, here we go. Favourite trick of plugging in e to the x, but then Larude has tried e to the minus x. Let's go. Let's try y equals e to the minus x, just to check what happens. With a polynomial, the degree goes down for each of these times you do a derivative. But with an exponential, there's no such thing as degree of this exponential function. So dy by dx would be minus e to the minus x. d2y by dx squared would be e to the minus x again. So if I plug that in, I would get there's an e to the minus x all the way through here. Excuse me. E to the minus x all the way through here. But if I pull it out, then you get minus 3, 2, and a 1. So this is true for all x. So that's lovely. It satisfies this for all values of x. To try and make it clearer why this is working, it's a very good called shot. I'm going to do something slightly odd, which is to put in here. Yes, Maxi, I agree. Welcome to chat. Sorry, Twitch tells me if you're first time in chat. You could put an A out the front here as well. Yeah. I don't quite know how to add that in. I think I'll put it down here. Very good. You could have a number out the front here. And then it would be, the A would just appear, because constant up the front, would just appear in the dy by dx and the second derivative. And any real A, or... Chat, you like complex numbers, right? Any complex A is kind of equally acceptable. Maybe we shouldn't do complex numbers today, but sometimes it's helpful to imagine... Yeah, I'm really not going to get away with this, but sometimes it's helpful to imagine x to be a real input, but y to be a complex number. Sometimes that's helpful, a complex function of a real input. Sometimes that's a helpful way to solve these problems, and then try and maybe, or actually, what you actually probably want is y to be a real number down the end, but you can sometimes get away with that. Yeah, there's other things you can stick in. You could put a matrix on, or you could put like a small picture of a fox or something, so long as you assert that this thing is linear under multiplication by a small picture of a fox. Anything out the front that differentiation respects. Now, if you tell me to put a matrix out the front, then you're fine. Then we're good. Cool. So somehow I think I want to stick to, for now, y to be y to be a function from reals to reals. Sorry, this is the sort of setup that I should have put at the front, right? To say what are the letters in here. Say x is real and maybe y is a real function. Maybe that should be my setup for what's going on. Anything that doesn't change when you differentiate. It kind of doesn't matter. Real number, complex number, cocker spaniel, whatever. This is called taking an idea and running with it. If I look at the chat history there, Maxi says a e to the minus x for all a, and then we went really for all a. Right, okay. I think I'm going to imagine it being a real number, at least for a bit. Okay. To make it, I said I was going to make it clearer why this works, and to make it slightly clearer, I'm going to put -1 squared in here. Now, I know that's 1, but that's morally that's what's going on, right? We had a minus sign, and then we got another one. Okay, fine. That's equal to 1. That's the longest I've ever thought about that. But if I put it back in here, then what I can show you is, aside from the e to the minus x, this is good. This works because minus 1 squared plus 3 times minus 1 plus 2 is equal to 0. Those kind of coefficients with the minus 1s from differentiating. Yeah. Also works out. So where I'm going with this is in fact, if you try y equals e to the mx, then you get a pattern not of minus and minus 1 squared, but you get a quadratic. So I think this is what Percival 1967 was saying in chat, that there's this kind of quadratic equation that you can associate with the, there it is. There's this quadratic equation that you can associate with the differential equation. And because of how differentiating exponentials works, once you've seen this, you get a way to solve it. Excuse me. Okay, so our strategy then is something like, hi Anders K. Our strategy is something like, when you see a differential equation just like this one, convert it to a quadratic equation, solve the quadratic equation. Now use Maxi's trick, because Maxi is probably in chat typing at the moment that we could try with a like a B out the front here, or even that we could add them together like Percival says. Even we can add them together. Thanks, Percival. So, kind of general solution. This is about as much as you learn in A level, by the way. There are a couple more tricks, but I'm going to show you over the next, goodness, however long we're live for. But in fact, this is all of the solutions. Not obvious, right? Because we've just been messing around with exponentials. Not going to prove it today. And in fact, this works quite generally if you have other numbers here and here. You can just do a trick like this to find two exponentials that work. So, at the moment, if you're in A level at the moment, I think you don't know any techniques. I don't mean this as a diss, but I think you don't know any techniques for proving uniqueness of a solution. Which is not a diss, just I think that's chronologically where we're at, right? Yeah, I'm trying not to do the proof by intimidation or proof by, yeah, sure, whatever. So I think my mic's a little bit hot. Gonna try down 2 decibels just to see, stop blasting your ears off. Let me know if I'm obnoxiously loud or obnoxiously me. But yeah, the technique in general has to be, so the technique for proving uniqueness has to be something like, suppose there are 2 solutions and prove that the difference between them is the constant 0 function. Now, that's the most basic way to prove uniqueness. You have to do some work to prove that, aha, the difference would satisfy blah. Then there's some reasoning to explain why that would be the 0 function. Now here, that doesn't even make sense because there are 2 solutions, e to the minus x and e to the minus 2x. You need to do something a bit more subtle, which is perhaps to write down a general solution minus... Yeah, I've got myself confused. So the proof... Oh, maybe Twitch is helping out my volume anyway. Maybe Twitch doesn't want to blast your ears. Okay, thanks, Lurid. There is this concept of the dimension of the solution space, which Anders has mentioned in chat. Not sure how much I want to say. Generally, for these linear second-order differential equations, which is what this is, it's second order because of the second derivative, It's linear because you can do this stuff that Maxi's been suggesting where you multiply and add together, and it's all fine. Linearity is great. In general, those have two solutions. Nth degree has n solutions. It is a matter of dimension. In a way, yeah, I'm never gonna get away with this. But this is a bit like a 2D vector space. You've kind of got so what is a 2D vector space, right? You have like two vectors, maybe the I vector and the j vector for your 2D space, and you can put prefactors on them, a and b, these kind of real constants out the front, and that gives you a span of all of what 2D space is. That's just what it means to be a 2D vector space. That you've got these two particular vectors, I and j, and then you can do linear combinations of them, and that's fine. Plus, there's like these a and b follow some particular rules, but not right now. And fine, okay, these things they're not underlined, but they are kind of a bit like vectors. Toast Potatoes is very into this, I think. And Larude wants to go on the quest again. So it's not a field, it is just a vector space. We had some stuff in the Quest for the Quintic where we saw fields behaving like vector spaces. A field is this kind of beautiful structure where you can add and multiply and divide and stuff. Essentially, in a field, the A's and B's behave very nicely, and also the vectors behave very nicely as well. You can multiply and divide them. Now my function space is a bit like that, isn't it? Except I'm very worried about dividing by 0. I've got a feeling that the function space is a ring rather than a field. Good job, Larude, you've set me off on a direction back. The things like the words I'm dancing around and trying not to say are that the A's and B's belong to field, but the I's and J's, the vectors, only have to belong to. Oh gosh, they can be anything, right? Yeah, together with this idea that you can do them. Oh dear. Yeah. Oh, good. Okay. Yeah, I used some Oxford notes. I later asked the students. So after my week of reading Galois theory and learning Galois theory from Oxford lecture notes, I talked to some students and I told them that I'd been learning Galois theory from lecture notes. And they kind of misunderstood and they thought I hadn't started. And they said, right, yeah, you've got to get, and they named somebody's lecture notes, you've got to get Balazs's lecture notes. You should definitely use those ones. They're really good. They're really easy to follow. They didn't realise that I'd already spent a week on this. And I said, I've actually been using some different notes. And they said, we found those ones very confusing. Really do think you should use these instead. So my students recommended me some other notes, which I didn't find as comprehensive as the ones I actually used for the week. So I was quite happy with the ones that I used. But I suppose lesson about learning maths at home, right? The common advice for learning stuff at home, whether it's Galois theory or not, is with the modern internet, there's no shortage of materials. The thing that makes the difference is the way you use them, the way you study with the available resources. That you can just find the resources anywhere, and then you put the work in to study things properly. But in reality, there's a lot of resources, and you should look at several ones and choose the one that you like the most. When can we expect to hear anything? Over the course of the next week. So I'm working to get a statement from the department. I don't want to guarantee Monday, but I think the department should be making a statement quite soon. Not with the full detail of what happens next, because we're waiting for special consideration forms. There's some processing there. I'm sorry it's taking so long, but we want to get lots of information before we make a decision. From our point of view, we've got more than a month until shortlisting, which might be enough time to do something a bit different. It might be enough time to do something of arbitrary amount of drastic. I know the English department made a decision very quickly. I'm a little bit jealous of the English department making a decision really quickly and putting something out that says what they're going to do with ELAT. It's much more complicated in maths, I think, because of the sheer number of applicants we've got, because of the diversity of problems. Our test was, I think, earlier than the ELAT. I think we started a couple of hours more, and we're affected in different ways. There are issues around regions. It's extremely complicated. And also the English paper, I understand, had a massive error on it, which I'm not saying is good, but from the point of view of crisis management, at least makes your decision a little bit easier. Let's say this is not a moaning stream. It just sometimes has some moaning on it. I know that gets you demonetized, which is something I can now be. The maths. I think I can reassure people that the outcome is not going to be. Oh, can I even say this? What am I allowed to do here? I think some people are worried. Some people are worried that yeah, exactly. What happened? Yeah. We're looking into it. We have some ideas about what happened with our third-party administration partners. We are following up with them to get more information about what happened, precisely what happened. We're getting people to do the special considerations form. So test centres have a form they can submit if something went wrong during the test. That's a lot of test centres this year. What people are, I think, worried about when I've seen the media coverage of this, some people seem worried that we'll just carry on as normal and mark the mat and use those scores like normal, and that will be unfair for people who had different amounts of chaotic experience. And I personally don't expect it to be a normal round from here on in. Would have liked it to be a normal round from here on in, but I don't think that's going to be how it works. This is maybe not funny, but I feel like I've been doing this for about 5 years, and what I really want is a simple year where it's the same as the previous year, and I haven't had one of those yet. This is not a simple year. We're going to do a lot of complicated things. Don't think about me. It's about 9:30, I think. About 9:30, where the official support line got overwhelmed at about 9:30, which meant people started phoning anyone whose number they could get, most of which were forwarded to me. I don't particularly like phone calls. I'm a millennial, and we were handling phone calls coming in while we were getting other phone calls in a way that the poor receptionist, I feel most sorry for the receptionist, could not handle all of the calls we were getting simultaneously. And well, I don't have any more information than anyone else. I don't want pity really, but every time the mat's happening, the mat's run in test centres with administration by a third-party company. My team writes the questions, and then during mat, I sit by the phone, absolutely panicking that something's going to go wrong. And this year, something did go wrong, really badly. Rouge was with an invigilator for 5 hours. Yeah, it's not okay, right? It's not okay for schools. It's not okay for test centres. It's not okay for anyone. I want to hear from people, Asher. So I would encourage you to do the special considerations process. I know that the English language admissions test people have said that they're just going to abandon the whole exercise, and that they don't want people to do special considerations anymore for them because they've just given up on the whole thing. Maths hasn't made that announcement yet, and maybe won't make that announcement. Okay, Trey, you want to ask about being sent a copy of the paper. My understanding is that a copy of the test paper was sent out to all. My understanding is that a copy of the test paper was sent out to all test centres at about 11 o'clock for them to print. No idea if that backup plan followed through or not. So as Toast Potato says, I don't currently know whether or not you got to sit the test. There's a special considerations form to say, look, I didn't do the test. I didn't get to do it because my test centre didn't print it. Or more accurately, for your test centre to explain what happened. It was password protected, and their password was sent in a separate email, by my understanding. And around 10 past 11, people started phoning me to tell me that they'd either received the test paper or the password, but not the other one, or both, or neither, or something. Yeah. Alfie, I don't think I've got the robot that does that. I'm excited to see if that does anything as well. Ignoramibus, I'm aware of allegations of mat test leaking. I'm aware of, if you're really careful, I can't comment on ongoing investigations. People are typing !Discord in chat, which doesn't show up in the. Ooh, it doesn't show up on that one, but it does show up on that one. Is that something I have to configure? So I have to configure what happens when you do !. Is it a robot thing? Or is it telling you what my Discord is? I don't think I have a Discord. Okay. In terms of time zones, my understanding is that some international applicants took the test very early, and then the chaos happens later on when candidates mostly in the UK took the test. I'm trying to find out more about that before the department makes an admission. Right, this is getting dangerously close to my job, and what I actually want to be doing is talking to people about differential equations. I know that's a really tone-deaf thing to do, to say, wait for the announcement when I'm in work. The kind of separation of people, right? Yeah, but I think I have to do it. Everyone assumes that I have loads of information, right? As soon as stuff goes wrong, people assume I have loads of information. It takes a surprisingly long time to get the right information and to see through what's actually happening. The very first phone call, I made notes. I wrote down exactly what they were describing because I wasn't sure I was going to hear about it again, and I've heard about nothing since for the next 3.5 days. My test centre isn't my school. Oh, test centre. Contact your test centre. Your test centre can do a special considerations form. I'm going to put a link in chat. Actually, I think if you're at an open test centre, then I think you can do it yourself. Yeah, one of the options on the form, so link in chat, one of the options on the form is I am a candidate at an open centre, so you can do the form yourself, I think. That is, no need to thank me, that's sadly my job at the moment. Okay, hi Robbie Gilmore, there should be a Matt in 10 Minutes video. I filmed it, I filmed it this afternoon. It's got a section at the front telling people about the link and stuff. Didn't feel right to release a kind of normal Matt in 10 Minutes video, especially because of the Matt very fast versus the actual very slow Matt experience. Didn't feel right. So we've got something like a Matt in 10 Minutes video. Social Media Manager might be releasing that later today or maybe tomorrow. Social Media Manager is also getting quite a lot of flack for some third-party server going down. Alfie, I don't. What am I going to say? I can't see anything to stop you, right? Normally made by centres on behalf of candidates. If you're a candidate who took the own, please, yeah, okay. The instruction on the form is for you to your school or college to do it. Here at the school or college. Toasted Potatoes liked question 4 and has a friend where they've worked out the solutions. What's question 4? Oh, question 4 is the one where you walk along the parabola and try not to bump your head. Screw it. I also haven't put the paper up because it didn't feel right. That's going up at the same time as the 10-minute video, so either today or tomorrow. Ongoing investigations, everything. If you can't contact your test centre, I would say just do the thing. Do the form. There's a possibility we get too many forms to process, which is still information. If the department looks at the forms and says, oh yeah, this is a much, much larger problem, then that is still data. It was crunchy algebra. Crunchy algebra. But with a sort of punchy thing. Question 6 was very nice. I will let the computer scientist know that they liked that you're interested in trees. You see, that's what I wanted to do, right? In a perfect year, I sit by the phone for 2.5 hours, like, oh my goodness. And then afterwards, I get to talk about the lovely, lovely questions. Question 4 was this one. This is not how the question's phrased. Question 4 works like this. There is a parabola, and you are carrying a ladder vertically along the parabola. Like an idiot, you're never going to sway from carrying it vertically. The ladder has some particular length and the parabola is some particular parabola. You would like to walk down the parabola and up the other side, and what you hope is that you don't bang the ladder on the opposite edge of the parabola. If the ladder's too long, then as you go down, it will bang on this bit of wall over here before you've got a chance to go up the other side. The question 4 is about calculating what the longest ladder is. Or I suppose alternatively, if you're a very tall person walking through a valley, so you're very tall, walking down a valley, can you walk down the valley and up the other side without banging your head? That's the path that your head takes. Down here, you're sort of, whoop, and as you go around, it rotates around. There's a sharp point there, and then you go up again. The question doesn't ask you to find this curve. The question asks you to find a condition for the curve to not meet the parabola itself anywhere. Yeah, cool. Right, solutions video should come up quite soon. I'm not managing the separation of characters, right? So it's supposed to be unprofessional. But Alfie liked question 5. That's almost a full house, right? Is somebody like question 3? Alfie didn't like it, right? Crunchy algebra. Painful. I only got the first part because my test crashed. Question 5, I don't know. Oh, question 5 is your classic. Here are the Fibonacci numbers. Here's something else where the answer is Fibonacci numbers. Prove their equivalent. Recursion stuff, right? Yeah, it's a shame they don't quite line up. The SNs and the FNs aren't quite the same thing. It's like had to do 10 minus 3 or something. The idea being that you'd look at the left and right of the middle number and everything's kind of out by 1. It was messy, right? There you go. Long Pi username. Wait, that's actually its first time in chat, but I remember you from before. Are you a different Long Pi username from the other person with like mostly Pi? Hang on, can I find out about chat? Have I got 2 Pi usernames? No, I don't think I do. Right, good. Okay. Oh no, that's live. Oh, I don't understand Twitch. I think I forgot to say thanks Skylinks said for the follow. Try saw my question 4 and thought, no thank you, what have the computer science people written? Nope, looks like this one was written by James. Get out of here. Yeah, Toast Potatoes is trying to help de-anonymise their script. This is... Oh, Skylink's still here. There you go. Closed formula for... No, it's fine, I'm joking. It's not like I mark everybody's back page. Right, what were we doing? We were doing general solutions for these things. Can't remember why. 2D vector space was something Anders said, I think, which was a very cool thing to say. Let's write out vectors. You will not be surprised what happens if you have a third derivative over here. I want to show you some weird behaviour of these things, because normally you might get one of these differential equations where you see Oh, hello. Let's do some weird behaviour stuff. So here's another one, which, following our procedure from before, the steps are like try e to the mx. So we want to solve m squared plus 1 equals 0, but, uh-oh. Oh yeah, it's called, oh right, okay. A subscriber! I think you might be the first. And then Asher, oh, you have two simultaneously. Oh my goodness. If you haven't typed James, how many subs have you got? You would have got in there slightly first. But I think LaRouge takes the prize. I know both of you subscribed correctly by using Amazon Prime, which gives you a free subscription every month. And we got to see the new animation. I forgot it would do that. That's brilliant. I'm having a great time. Tasty Potatoes is trying to log into Amazon Prime's funny, exciting expression. God, that's really distracted me. Free trial for Amazon Prime. We are rinsing Jeff Bezos. This is amazing. Free trial. Wow. Hi, Brav. You right? I've paused at a moment with some complex numbers because people are subscribing. This is amazing. This is genuinely the silliest thing that anyone's done. Yeah, do some tips on factorising. Factorising is when you take a polynomial like this and you want to split it into two terms. And it's equivalent to finding roots of the equation usually. So for example here, I and minus I are roots. So you might factorise it like this. And that's how you could get your two factors of this quadratic equation. What sort of quadratics are you trying to factorise, Prav? Let me know. Give me an example in chat. Oh, yes, but it's the difference of two squares, isn't it? Because it's m squared minus 1 squared. Of course, how could I miss it? Well, so that's why it's m plus I and m minus I. No, what have I done? It's m minus, no, I'm wrong. I screwed it up. I screwed up the joke. Okay. So this has got solutions I and minus I, which gives you the brilliant solutions that y is a e to the ix plus b e to the minus ix, which is a bit weird. You've got, hang on, so you've got limits and factorising at the same time. I think I need an example. I don't. I know lots of things with lots of problems with factorising in and lots of problems with limits in. I'm not sure I can guess which ones you're doing there. I've got both. Okay, the normal thing that people do with this, by the way, is to rewrite this in terms of cos and sine. So if you know Euler's formula. We are currently doing about 4 sorts of maths at once, but that's just the sort of chill math stream that we're doing. Factorise, there's no x or 0 or sum. Sorry, paying attention. The rude. Oh, yeah. Wait. The rude wants me to go further. Also, I've noticed you've got like a little crown. Oh, that's for prime. And you've got first because you are a founder 1 month subscriber. The little hats are very exciting to me. I like those a lot. Yeah, thanks, Maxi. I don't know what's going on yet. I'm going to get there, but not yet. Chat is talking about a different sort of maths to me. People normally rewrite this a bit. I'm not sure if you'll like this, but maybe we could call this C and call this D to reveal our kind of alternative formulation where we just write down cos and sine. Cos and sine both satisfy, each satisfy this differential equation at the top, the solution to cosine and sine. And linear combinations of those, which in fact you can write as like this if you really want to, but there's tricks for expanding this back out again if you want to. But yeah, so playing around with it so that the solutions could be written like this, in this kind of AB formulation with exponentials, or equivalently down here in terms of cos and sine. And it's okay to write down either of those, really. And you know this works, right? Because you know that y equals cos x. Oh wait, do people know how to differentiate cos x? Like this. And then background again. So that when you add these two together, you get 0. I can never remember if it's it really saw me pause. I can never remember when people learn this. It's possible you haven't learned this yet. In which case, oh, you just learned this. Okay, brilliant. Look, cos and sine are solutions to this. The second derivative is exactly negative of the normal function. Yeah, but Maxi, who says anybody's doing differential equations? I just started a live stream and threw this on the board without checking. So it's possible. Who knows what I'm teaching people today? Factorise. All sorts of maths going down. I'm really pleased that we've got 3 subs worth of Jeff Bezos cash. Is it rude to call it Jeff Bezos cash? Do you get demonetised? Do you get banned for that? Is he a capricious overlord? He's kind of my boss now, right? Because Jeff Bezos owns Amazon. Amazon owns Twitch. Twitch owns me now. So, yeah, cool. Okay, we're not going to use this one. Disconcerting thought. I maybe work for Jeff now. Ignoramus. Very good username that I can't quite say. But I know what it means, right? It means someone who doesn't know things or something, which is a good attitude. So auxiliary comes from the Latin to mean help, and it's supposed to go alongside your original equation. So I think the word auxiliary, which people sometimes use for this in here, this quadratic, is called the auxiliary equation. The thing to imagine is it's kind of helping you solve. It's kind of alongside. You have your main equation up here, and then backup side thing over here is the auxiliary equation down here. I did Latin. I did Latin when I was 13, I think. Not GCSE or anything. I just had to have Latin classes at school. I went to this quite weird state school where, sorry if they're watching, I went to this quite weird state school that I think wanted to be like an old-fashioned school and teach people Latin and stuff. And I really enjoyed it. These days, if I know any Latin, it's because of etymology stuff. If you want to know where words come from. So, for example, did you know that statistics and state, like statistics like you learn in maths, and state, like a country, have the same kind of distant ancestor word, because statistics came about to try and understand your statecraft, your population, and your country level important statistics about a country. Like the CIA World Factbook is kind of the original use of statistics. So if I know any Latin, it's because these days hey, knowing where words come from is cool. What am I doing? Oh yeah, I've got cos and sine down here. A normal thing to do when you're solving these is when you make this auxiliary equation, helper equation, auxiliary, I can't even spell, equation. Google it if you would like to spell it or know what it means. Hang on, I've got it on the screen over here. Auxiliary equation. Something you might do is you might try to apply some sort of initial information. So this, by the way, represents a kind of it's called simple harmonic motion or something swinging backwards and forwards. It's a little model. It's not particularly accurate, but it's a little model for something going backwards and forwards because the solutions tend to be cos and sine. So you might have, and this is maybe too physics for everyone. Let me know if this is too physics for everyone, but you might have some sort of initial conditions, which might say with at x equals 0, so this is like the input. At x equals 0, I'd like y to be 0, and I would like dy by dx at x equals 0 to be 1, or something like that. You might have some conditions. Larute, so you can go from this line down here to this one. Yeah, it's a separate kind of trigonometry fact, that the sum of two trig functions can always be written as one kind of combined trig function. That sounds more fun than the thing I'm actually going to do. So finishing up my idea before I show Larute that, if you've got some initial information as well, you might use that down here to find out what C and D are. So we've got two unknowns, and maybe we've got a couple of facts. And like solving for the constants when you do integration, or like solving for the constant at the front of a polynomial or something. There's this weird thing where, okay, so I've made a big claim though about the sum of functions, which I'd like to try and back up. That the sum of two cos functions is another cos function. Let me try to show you. Okay, we're going to switch to a Desmos view. I think this works. Oh, please work. Yes, it's going to work. Woo! Here's Desmos. Cos and sine. And then I can do f of x plus g of x. And I get something else that is another trig function. Now I'm just showing you so it looks like a trig function, but you might have some observations that this thing, green function, really does look like a sort of trig function. I'll show you an equation in a second for which one it is, but look how it's slightly larger over here, where there's some constructive addition of these two functions, and it's slightly more negative over here, where there's some stuff going on here, and it could be zero. The green function around here is zero in between. The general thing that you can do is to say that, what do I want to show you? Okay, so I want to show you what happens if you have cos functions like this to start off with. So cos x plus cos 2x. In fact, I want to do cos mx plus cos nx, I think. That sounds fun. Yeah, there we go. Okay. So that looks pretty wild. So this is cos x plus cos 1.5x, and the green curve shows you the addition of those two things. It's a pretty funky function. I've gone off on one, sorry. Wave superposition. It's pretty cool. There's a formula in the formula booklet. This is kind of my answer, really. There's this formula in the formula booklet to say that the thing you get is something like, oh gosh, I'm going to get this wrong a couple of times while I try and remember what the thing in the formula booklet is. Not quite that. Not quite that. I'm out by causes and sines, aren't I? Desperately trying to remember the formula booklet fact. Now I'm out by some sort of factor. Why am I out by a factor? Factor of 2. There we go. Good. Okay. So my claim is that these are the same for any value of m and n. Okay. Cool. So adding together these different cos waves, which is not exactly what I was doing. I was adding together a cos and a sine, but there's something else going on here. You get this kind of product thing, which is perhaps a little bit weird to write the sum of two things as a product. It's the difference of two squares. It's not too exciting, really. Okay. By the way, the fun thing that happens with this, if I go back to just showing you the sum, the fun thing that happens is if m and n are very similar numbers, so if m and n are very similar numbers, what do I want to do? So at the moment they're like this, and you can do all sorts of cool stuff where, so if m and n are very similar numbers, then the thing ends up being like, oh, that's not what I wanted at all. What do I want? Oh, you can do all sorts of weird stuff. Whee! Waves inside waves. What am I trying to do? Oh, you can get very long waves, right? Very long waves. So if this comes down to like 1.1, then you get these long wave patterns like the Arctic Monkeys logo, where it's a wave inside a wave packet like this. And the waves get very, very long. But this means that your tone if you've got two very similar tones, I'm getting there. If you've got two very similar tones, so this is vibrating at one note, and this is a different tone or note or different frequency, very slightly different frequency, then when you add them up, you get this very long time between periods where the waves are adding together constructively and periods where the waves are adding together destructively. Let me show you the blue and red waves here. So you get this long period where sometimes the blue and red waves are lining up, but if there's just a small difference between M and N, then after some long time, the blue and red waves get more and more out of sync. Let's just turn these off for a second. The blue and red waves get more and more out of sync until they're destructive, but it takes ages. This is what, 45 on the axis. So together you end up with this pattern where it's kind of waves behaving nicely together and then waves cancelling out, but over this long time scale, which you can hear, if these are sound waves, you can hear that as if it's one perfect note that's being cut off and opened up and closed down, kind of throbbing, vibrating modulation of the single note. That's a phenomenon called beats. The thing to Google is beats, which is so the phenomenon's called beats. It is a horrible artifact that makes audio sound really bad, which is why I find it really funny that those headphones are called Beats by Dre, because Beats is like this awful, horrible noise that's a sign that your audio is actually horrible to listen to. It's not what I would have named my headphones after, let's just say. Good. It's kind of like a long period of throbbing. Ugh. Sorry. Get kicked off Twitch. Speedrun, let's go. It's been a weird live stream already. Yeah. So the wee noise is different pitch, whereas this is kind of different amplitude. Yeah. Let's try and do ops with Dr. Dre. Let's see what happens there. At least I remembered him. Right. Okay. This was this tangent was brought to you by Larud. I've just seen Asher saying that you had 3 copies of Emperor's New Mind. Amazon's a funny company, isn't it? That tangent brought to you by Larud. What I actually wanted to show you was some weird kind of... This is probably not going to be as interesting as I thought, but something that my second year students are about to discover later in the second year of university, let's go quite late on in a maths degree really, is that when you're trying to solve for C and D down here, you've got 2 equations, right? So y of 0 equals 0 means, so if I plug in x equals 0, well, the sine will go away, but I'll get some cosine. That means that c is 0. And do y by dx at x equals 0 means, well, something slightly more complicated. I've got to differentiate both of these. That means that c sine x minus c sine x plus d cos x at x equals 0 should be 0, which I think means that d equals, there's supposed to be 1. It's 1 up there. 1 up here, so 1 down here. So I think that means that d is 1. What my students are discovering, or about to discover, later on in second year, sorry, I'm thinking about last year's students and this year's students, it's weird. What my students discover, or are about to discover, is that when you're given 2 facts, sometimes you get 2 equations that you can't solve. The weird thing is that at A level, that makes perfect sense, I think. Sometimes you've got a system of equations that you can't solve because they're just inconsistent. But over here, this means that sometimes an innocent-looking differential equation might have no solutions because of the extra information you've given. the extra information might be 2 facts for your second order differential equation, which is normally fine. Normally gives you 2 equations. So down here I've got 2 pretty basic equations, c equals 0, d equals 1. Couldn't have got more boring equations if I tried. But sometimes, depending on the information, it comes back, with boundary conditions. And the thing is, now, at the moment, that when you solve a matrix problem like this, and this is kind of secretly a matrix problem, 1, 1, 2, 2, CD, that's 1, 0. And when you solve a matrix problem, you sometimes get infinitely many solutions, no solutions, or just one unique solution. But the problem is that first order differential equations are quite well behaved. First order differential equations are quite nice. It's second order differential equations with 2 boundary conditions where you start to get interesting effects from the determinant of the matrix being 0, even if it was none of the terms were 0. Gesticulate. I have this ongoing problem with maths that you learn in A-level, where a lot of things you learn are kind of 1-by-1 matrices disguised as numbers. So this is a 1-by-1 matrix, and this is the number 3. And this is kind of fine because in A-level often you've got 1-by-1 matrices. Hi, Elemental99, thanks for the subscribe. And hi in chat to, who did I see? Hi, Alistair Bishop, who's got, I remember now, the Good Luck Have Fun Pledge badge. Oh, I'm obsessed with badges. I should look into that, find out about those. This matrix is not good, yes. This one in my example down here is pretty awful. It's pretty quite bad news. It doesn't always mean there's no solutions, because even if your matrix has 0 determinant or rank 1 or something, you might get lucky. For example, if I put a 2 here, then instead of 0 solutions, this now has infinitely many solutions. Yeah, Anders says it's might have solutions, but it's not going to be a unique solution. And there's that word again, this uniqueness of solutions. That again, you don't do any of that at A-level, and you do some of it at university if you do a maths degree, because it would be good to know if this had solutions or not. Yeah, so here's an example, I suppose. No, let's go over here. So we've just seen there's kind of general solutions of this harmonic motion problem. And here's something that looks reasonable but is not actually good. This looks pretty fine, right? We've got a second order differential equation. We've seen today that those are going to have these second order differential equations tend to have 2 solutions. But we've got two facts. So our plan is to go and solve that as y equals c cos x plus d sine x, and then try and apply our conditions. So we try and plug in y of 0 and y of pi. We would like this to be 0 and we would like this to be 1. But if I plug in 0, I get c, and if I plug in pi, I get c. So this is now these are kind of very bad equations. Once again, I've written down something that's very basic if you interpret it as a matrix, but the idea is still there that these equations are inconsistent. Right? They don't tell me anything about D, and they tell me that C has to be 0 and 1. Oops. That's pretty bad. And this, in terms of the simple harmonic motion model, in terms of a pendulum, I'm going to do physics for 1 minute. In terms of a pendulum, that's because a pendulum has a period of oscillation that's independent of the initial conditions, the initial position and velocity. So if you want it to be somewhere at x equals 0, then at x equals pi, that's half a period later or something, it's going to be at 0 again. It's going to have come back. Or I suppose, yeah, it's going to have come back, which means you can't say that it has to be at 1 there. Kind of these boundary conditions try to violate the law of period of oscillation being independent of initial conditions. But that's an appeal to a physical law of physics, and that's not how we do maths. It just seems like the maths reason is I've written down a solution and found that there are no solutions that work with this. Yeah. Oh yeah, the equation is something to do with a pendulum. Would you like that? It's not a very good picture, is it? So the idea for the pendulum is you've got displacement, which people normally call theta or something, but I'm calling y, so that I can keep using the same letters. It's like y positive is this way, y negative is this way. I know it's a bit stupid to have y as a slightly curved horizontal axis, but roll with it, I suppose. And I suppose I'm using x for time. Look, well, people normally do theta of time, so let's go theta of time for like what the angle is. Then your pendulum has got an acceleration, which is something like dt theta by dt squared, and it's got a force of gravity, which is something like theta. There's just a little bit of gravity in the direction of, in the tangential direction. So it's this, I said I'd do 1 minute of physics, and now I'm doing quite a lot of physics. I am doing displacement as angle, so I regret labeling it up here. There we go. Now I regret having it on the left. Maybe that's how I can. Is this possibly the worst diagram anyone has ever done? There we go. Wait, I can save this. I can save this. Good, okay. Pendulum. Got a long stick with the blob on the end, and you're talking about theta. So you've got to think about circular motion equations. There's an acceleration in the tangential acceleration is something like the second derivative of theta with respect to time. Radius is constant. And there's a component of the force of gravity. So gravity acts straight down, which has a tiny little component. It's actually more like sine theta, but that's like theta if theta is small. And it's possibly got a negative sign on it as well. Yeah, anyway. These two terms are kind of thematically related, let's say. So that this is a little bit like the pendulum equation, but with y's and x's instead of thetas and t's. I regret all of this, Larude. What does potato say? If these two boundary conditions are true, then we can't write y as a single trig function. Ooh. Yeah, so you know that the general solution is r cos x minus alpha, which has a kind of known period. Yeah. None of them fulfill both of those conditions. Yeah. You need, halfway through your reasoning, you need to sort of magically, the period of oscillation, or like the coefficient of x in here, in general it could be something else in front of the x, but here, yeah, we know from our general solution that the period is like this. And actually maybe writing it out like this with the combined trig thing is better. I have not seen the horror movie for Summer of Maths Exposition 3. Maybe I should watch the 3 Blue 1 Brown thing and the horror movie. Plot summary, not very big on horror. Hang on, I want to do a little trigonometry corner as well. Trig corner. Trigonometry corner works like this. I try and remember how that fact works. So there's a way to multiply this out that I do remember from the formula booklet. It works like this. It's cos x cos alpha. Do I remember this from the formula booklet? Plus sine x sine alpha. So if you want that, if that's equal to c cos x plus d sine x, then everything is okay, provided you have r cos alpha. Then r cos alpha should be C, and our sine alpha should be D. So idea is to do tan alpha would then be sine over cos is D over C, and R would be something to do with C squared and D squared, right? Okay, brilliant. So over in trigonometry corner, I think for Leroux, who hadn't seen this before, if you see this combination of trig functions like this, then you could set tan alpha to be D over C, which, I mean, you'd take an arctan or something, and you'd set R to be this. And you'd be quite careful with minus signs, because I'm very, very nervous about plus or minus signs in all of this while you're doing your roots and stuff. And then it would maybe line up with, it would agree with this thing on the right-hand side. I've been linked to a YouTube video. Let's watch that at some point. He started writing velocity as r dot. I am quite fond of x dot like that for vector velocity. Oh, hello VG Craze. You've added me and I'm also live on the stream. But the map, will Oxford release a statement? Yes. A lot of work been going on over the last 3 days. We are working with the Central University's Public Affairs Directorate. AI horror. I'm not doing the statement in my personal Twitch stream. I think that would be weird and also stealing the thunder. Plot summary. There's an AI who has trauma. She keeps drawing pictures of these puppets instead of what she wants to do. They try to fix the trauma using the Jacobian to enter the AI's mind and edit it. Oh no. So that the puppets do not have a highway in the eye. But I'd like the idea of spooky puppets coming out of an AI, whatever you ask for. Is that it? Oh, you're from Unique. Hi, VG Grace. I said it'd be fun. When I said it would be fun, I did not mean you'll be locked in an exam room for 4.5 hours and stuff like that. That was not what I wanted. Questions were supposed to be fun. Maybe one day I'll be able to talk about the questions. Oh, LaRue wanted to go on Uni too. You missed number theory. I taught some number theory. We also taught some matrices and Markov chains. No reason why I can't do that now, to be honest. Bit cheeky, isn't it? VG grades. What was the best bit of Unique during the residential? If you're in chat, what was the best bit? That's the trauma. The Jacobian has a million of entries because the IA is cleverer than we thought. So they have to approximate the Jacobian. Ah, right, now it's getting educational. Right, I see. Bazoo! Yeah, let's do Bazoo. Elrud, do you know Bazoo? Elrud. You learn Bazoo quickly. This is kind of a request show. I know that sounds mad, but it's kind of like... Saw a request. You saw it for the Galois theory. Ah, yeah. I kept skipping it for the Galois theory stream. I kept skipping it, saying, no, I know this already because I taught it over the summer. Let me show you the Markov chain stuff very briefly. So you are learning. People in chat are very keen on Bazoo. Maybe I'm doing this wrong. Okay, I'll do a Markov chain very quickly. Very quick intro to Markov chains. And then down here, very quick Bazoo lemma. Okay, so, you can do it in school. Is that the thing used to prove that Z mod NZ is a field when n is prime? Yes. But that's a slightly funny way to put it. Thanks for the follow, VJ Craze. Here's the very quick intro to Markov chains. You have been asked to design predictive text for sheep. So the sheep, we've developed these mobile phones for sheep. Actually, draw sheep. Just make it look cute, and that'll be good enough. Now, it was quite hard work making the mobile phones for the sheep, but luckily sheep communication is mostly just 2 letters because sheep mostly just want to say bah. And this sheep is typing. So it's got an A button and a B button. These are buttons that the sheep might try to press while they're trying to spell whatever they want to say, like to send ba 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 ba. Now, what you could do is just guess that it's 50-50, right? You could just say, okay, if I want to make an AI that talks like a sheep, maybe it's just 50-50 A's and B's. So maybe I'll design some system which just throws A's and B's and just guesses what the next letter is going to be. And that's all right, but the sheep are not very happy because it hasn't really captured anything about their language, right? The sheep can either press an A or a B while they're typing out their text messages. So maybe after a while you realise there are more A's than B's and you up it to like 60-40 A's and B's, but you still haven't really captured it. Excuse me. The output that you get is still not quite catching it. So what you do is you have different probabilities, different depending on previous letter. That is the only idea behind a Markov chain. You kind of have states. You look at the most recent letter and you see, was it an A or was it a B? And you say, well, if it was a if it was an A, then there's some quite high probability that we have another A. So I'm drawing this arrow to mean you are here in this state. You just had an A. If you type another A, then you'll run it back again. Maybe that's 0.9 for a repeat, which means that 10% of the time an A is actually followed by a B, and from a B, maybe it's something more like 999 or something, 0.01. For another B. They hardly ever say 2 B's in a row. This is a slightly more complicated model because look, it's got 1, 2, 3. Well, they have to add up to 1. So it's got two independent probabilities going on. These switching probabilities, if you like. These 2 independent probabilities, whereas our previous model only really had 1 number to describe it. So you get more complicated behavior out of this. This is an automaton, and with its states and its probability of transition. Automata are usually deterministic when you learn about them in computer science. They would say something like, you're in state A, therefore, based on some like input tape or something, you go to this state over here, B or C or something. Whereas in Markov chains, the decisions are made not based on input or based on particular choices, but they're based on random chance. So if you do 100% probabilities, then the output you get, the output of this model is B at the start. If the sheep, you need a starting condition, but let's say the sheep presses B to start off with, and then A forever. Or if the sheep presses A at the start, then A, which I guess imitates a sheep quite well. The thing that, if having a small return probability lets you do stuff where it goes back and starts a new bar. And maybe the weird thing is that this does a better job of imitating sheep speech than the random A's and B's. If you just look at the previous letter, you do a better job of making a slightly more interesting output. The more advanced thing to do would be to look at the previous 2 letters. Let's try and draw it. The previous 2 letters would be, your states would be like this. Now, maybe this one almost never happens, that a sheep has just said BB or something. Maybe that one almost never happens. And maybe the AA one. Oh no, that happens quite a lot. But you can imagine setting up probabilities for what would happen next. And I mean just for the next one letter. So over here, if the sheep's just typed AA and its next letter is an A, then that's a return. If the next letter is a B, then it's this. Over here, and those are the only possibilities. It can't go straight from AA to BB as its most recent 2 letters of history. So this is a kind of interesting network. If you've ever played one of those games with like heads and tails, where you're flipping heads and tails, and the first person to get a particular sequence wins, then you can model that with Markov chains as well. These kind of things where there's a state of what's currently happening and probabilities to move between them, which might be 0 or might be like 1/2 or something. So you can build a really complicated model of sheep speech down here, I think, where the nodes, I guess, look like this. That one loops to itself or goes to BA. BA could go back to AB, or it could go to AA if you have another A after there. And all of these need probabilities on the arrows to express what happens next. And that'd be quite a complicated model of sheep speech. I have no mouth, but I must scream. It's not the A's. Good stuff. So if you want to build one that speaks English, then you'll need a lot of states, too many for me to draw, and you might like to look at more than 2 letters, so you might have really like n squared states if you just look at the 2 most recent letters. But that's sometimes enough to work out if you've typed TH, then maybe the next letter is E. And then you start to look magic. I mean, E is the most common letter anyway, but if you up the probability so that if you see a TH, then it's really likely to say E, then it starts to get spooky. Predictive text is no longer spooky, I think, but hey. In some sense, just juicing these probabilities a little bit in these different situations based on looking at some of the history, so that it's not just random each time, it's random based on recent information. That's Markov chains in a nutshell. You can do some beautiful theory to analyse these things, to talk about the long-term behaviour of what's going on. There's kind of some long-term probability that you're in each of these states, P and Q, let's say, and then some linear algebra to tell you like the long-term mixing. If it's settled down, the long-term probabilities. It all comes back to matrices, recurrence relations, and pretty much the same maths as before. The Matt has done a question about automata, which looked a bit like this. I don't think it had random probabilities in. I think it was deterministic. Yeah, it's linear algebra, right? Because here's the linear algebra. Quantum. So let's try and analyse this question. What's the kind of long-term probability of A or B in this model here? In this model here. And now that was the thing that we were setting. It was easy to work out because it was like 60-40. That was just the split that we programmed in. Whereas here, because of our complicated model, we've kind of lost track of that a little bit. We can calculate it though. So quantum mechanics asks you to think about the kind of superposition of maybe this or maybe that at the same time. It's a bit wishy-washy perhaps. But let's imagine we've got, I don't know, 1 million sheep. No, let's do 100 sheep, and they've all been texting for a long time. So there's no kind of weird superposition here. It's just true that some of the sheep have just typed A and some of them have just typed B. There's kind of some number of them have each done that. Now, what happens next? You've got maybe P and Q as the, if I stack them in a vector for what's about to happen, and for the number of sheep out of 100, so these are kind of percentage probabilities, but the number of sheep in each state, well, a very small number of the A pressing sheep are now going to say B, but most of them are going to say A again. So most of them are now going to say A again. So there's this kind of matrix that gets applied, if you like, to take most of the A sheep are going to say A again, and some of them are going to say B, and down here, most of the B sheep are also going to say A. And what we'll get is, if this is the long-term probability, then after the sheep have pressed another button, they're probably kind of still in the long-term probability. So these equations are probably supposed to give me back P and Q again. This is not the quick introduction anymore. This is now analysing the probabilities using. There's a lot of linear equations, The linear equations kind of come about because a certain proportion, a certain amount of the A sheep now go over here, a certain amount of the B sheep. So the total number of A sheep you've now got comes from two different reasons that have been added together. It's just very linear. That's the linear bit. These are eigenvectors. So the question of finding the long-term probability is just a question of finding an eigenvector. Arbitrary matrix thing. Yeah, there we go. The structure's really good and comes down to finding eigenvectors. People on the Unique Summer School, is VG still in chat? People on the Unique Summer School, we taught them about eigenvectors quite slowly, and like it took a long time to get to eigenvectors. I don't mean we taught it particularly slowly, just I've got him really hot. And in Unique we obviously have more time and taught it more carefully. And maths that came out. Yeah, finding something is invariant. Invariant is what I'm really trying to say, I suppose, instead of long term. Eventually invariant, which isn't always true. You can design a sheep simulator that just says this one never settles down into a invariant status or a long term thing, because this text generator is programmed to always go deterministically A, B, A, B, A, B, like a pendulum. A, B, A, B, everything's linked. A, B, A, B. So it never settles down. So that's kind of a little bit disappointing. The eigenvalues of this matrix. The eigenvalues of this matrix are the solutions to lambda squared plus 1 equals 0, which is the equation we had before, and I swear this is not scripted. Right, it's all linked. Okay. I'm so pleased that came back round to the same equation down there. Good. So sometimes these things settle down, and sometimes they don't. Can I try the 1839 trick on people? I don't think I've tried this recently. I can do the 1839 trick. Yeah, this is a plan for a number file video. So we're going to test it out. It's 3:30. We'll do Bazoo in a minute, but I want to test out my pitch for a number file video. You can let me know if this will work or not. I don't think it's been done on number file before. And that's part of what I want to explore here. I'm now just testing out content. This is the main plan of this chill stream, right? Can I test out some content? I would like you to choose 3 numbers. Also stop me if I've done this before. I guess they should be positive whole numbers to make the next bit easier. If you're playing along at home, let me know. They neither confirm nor deny. They're a paid actor. We're all being paid Jeff Bezos money, right? Yeah, video. Oh yeah, okay, these are some pretty good numbers. Yeah, cool. I was also going to say don't tell me, but this counts as chat interaction, which gets up my metrics. So very nice, very good, very cool. Right, here's what I would like you to do. I'd like you to repeat the following. You may need a bit of paper and a calculator. I would like you to add them and delete the smallest. So you'll take your 3 numbers, add them to make a 4th, kill off the weakest one, repeat. So to take, I'm gonna take Elrude's example, L, 7, 12, 3. I like that they're not in order. So if I add them, I get 22. Delete the smallest and then repeat. So I add 29 and 12 is 41. Kill off the smallest and I keep going. And I'm going to get Elrude. Did potatoes maybe slightly regrets choice of numbers. I will allow you to cross out everything after the 1 if you like. And I'd like you to keep going until you get bored. The reason I like this trick, by the way, is we'll get there, but I mean, spoilers. It doesn't matter what numbers you pick, and for what I'm going to do, it doesn't matter what numbers you pick, and it doesn't matter how long it takes until you get bored. Sometimes these tricks are really precise, right? Sometimes these tricks are like shuffle the cards, put them back, do it again, and now it's it's underneath very precise manipulation. This one's not like that. This one is just you get there in the end. So we're going to keep going. 3 squares after 2 steps. That is cool. That won't stay like that. Whoa, big numbers. Okay. So people may be writing some computer code, so it depends how much adding you want to do. If you get bored very slowly, then you can get those numbers quite large. Hang on while I Google something. This is a pitch for a number file video, right? So you imagine I'm there. I say Brady, pick 3 numbers, and then we do some adding. So Brady's doing some adding, or maybe I'm doing the adding. I don't know. So it's all very exciting. You're getting much larger and larger numbers as we go along, and there's no obvious pattern to those numbers. So everyone's having fun. Toasty Potatoes are going to write some code for adding. It is good if you get the numbers a little bit large. I think we're probably there. And then I want you to divide the largest number you've got by the second largest. Now this is the bit where emotionally I love it. This is the bit where maybe you get excited that you've proved that this is not okay. Actually, I've got time here. I'm going to let people try this out. Yeah, okay. Laroud's put something in chat. VGTrade's pretty similar. When I've tried this with people, they've generally looked concerned for me because it feels like it should maybe be the number 2. It's quite close to 2, but that's not quite the number 2. The number on my bit of paper, which I suppose I should make first for honesty reasons before people start telling me in chat, is 1.84 ish. 1839 trick. Yeah, VGTrade. I was going to say 1839. It sometimes takes a little while to settle down. So it only works asymptotically. I could work out how long it takes, but I haven't been quite bothered to work out how long it takes yet. So you're not wrong. I just maybe I needed you to do a bit more adding before it gets there. It's like that, yeah. So Maxi, it's like the Fibonacci numbers, except 3. So Tribonacci numbers, and also you got to choose the start point. You got to choose the starting numbers. So you kind of invented your own stuff, right? Like how Fibonacci invented something, 1, 1, 2, 3, 5. I've got you to invent your own sort of Tribonacci numbers that start 2, 1, 3, 7, billion and 6 or something, or the ones that start 7, 11, 64. 2 questions you could ask here. Why? And what's that? The exact value of that number that you're calculating, the one that it settles down to. If you did more adding, it gets closer and closer. You saw in chat that some people's numbers were slightly different from each other, but if you keep adding, if you keep going, they'll get closer together. So you're getting closer to something. What is it? 1.839. Yeah, Toast Potatoes. So is that? Have you gone further there? Let me have a look. Oh no, it's your number. Yeah, okay. You've come back with 1.839. And look. 100 steps from your starting numbers. And so if I compare the username with pi starts 1.839287, whereas Toasty Potatoes 1.8392867. Yeah. Those are pretty similar numbers. So you might try and guess what they're converging to, getting closer to, and you might think that it involves 3 and adding, and you'd be right, it involves 3 and adding. Is 1 plus the cube root of 19 minus 3 root 33 plus the cube root of 19 plus 3 root 33. all over 3. Which I think deserves to be on number file as a number. Yeah, now we got the y. Now we got the y. Yes, you could do this. Yes. This helps you convert between meters and the James meter. Yes, the standard unit of whatever problem we're doing at the moment. Do people generally know? So to pull up a comment by Maxi just there that you can use Fibonacci numbers to convert between miles and kilometers, because the ratio of large terms for Fibonacci numbers is the golden ratio, which is pretty close to the conversion number for miles to kilometers. This is just a good fact. Vicky Neal did a short video on this a while ago on social media that I liked. Let's see if I can remember how it works. 8 miles is about the same as 13 kilometers. You pick your 2 favorite Fibonacci numbers. It's kind of about right. So the answer for why this is happening is auxiliary equations. Okay, so you're going a little bit further. Let me write out the number that I think you're calculating, which is this number here is 1.839286755214116. What did you say in chat? 1.839 in chat, 286755214116, and then you've got a 2 afterwards. And I've run out of digits. Oh no, I can ask. And then I've got 11325518553. But Toast Potatoes and I now agree to 6, 9, 12, 14 decimal places or something. Yeah, Maxi, is there an explicit function for the asymptotic ratio of an n-valued Fibonacci sequence? I can do better than that. Here's the equation that we might like to try and solve. We might like to try and solve something like f of n plus 2, or f of n plus 3 or something, plus... so the one I've been getting you to do, there's a small red herring about get rid of the smallest one. After a while, your numbers are just in order, so I'm just getting you to always look at the previous 3 numbers, but yeah, anyway. So here's the equation that we've been working with, subject to your initial conditions. You set up some initial things, whatever you want your numbers to be. But there's some equation in here for how these things work, and I've moved everything onto the left-hand side. Yeah, if you just have the numbers in order, then it works. It's a little bit me being cheeky to try and make it seem more powerful than it is. I could just tell you to list them in order and then delete the first, but where's the fun in that? Okay, I've moved everything onto the left. We would like to solve this. Now, there are things we could try. So we could try things like fn equals 0 works. Fn equals, other constants don't work. Fn equals polynomial in n is promising but doesn't quite work. In fact, a good thing to try is try fn equals lambda to the n. Oh, let's go lambda to the n for some constant lambda. Now if you do that, you get lambda to the n plus 3, take away lambda to the n plus 2, take away lambda to the n plus 1, take away lambda to the n equals 0, and you get, well, if I divide by, this is supposed to be true for all this is supposed to be true for all n, so if I divide by lambda to the n, we're going to get lambda cubed minus lambda squared minus lambda minus 1 equals 0, which is just some cubic. Yes, we're going to get some sort of cubic, and you can solve that. It's got a real root that's about 1.839 with the cubic formula that I showed you on the previous page. And it's got 2 imaginary roots, or 2 complex roots. The general solution, which I'm going to call lambda 1 and lambda 2, that's lambda 0. the general solution is a times 1.839 to the n, dot 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 in here, plus lambda 1 to the n, plus lambda 2 to the n. There could be b's and c's out here. And these things out here, you might be very scared about them. I haven't told you what these are. I haven't told you what these are, but they're complex numbers. They've got negative real parts, which means that they tend to exponentially decay. And they've got some complex part, so they oscillate. The complex part corresponds to this kind of cos and sine stuff for this to be falling apart. For this to be so, the general behaviour is that after a while, no matter what A, B, and C are, so A, B, and C depend on your initial numbers in some sense. Complicated to go and solve that. I'm not going to, because eventually these things with their negative real part in lambda 1 and lambda 2, lambda 1 and lambda 2 have, do I mean that? What do I mean? Whatever, I'm rolling with it. These terms have exponential decay. Not quite sure about the real part. These terms have exponential decay. They get smaller. Oh, it's like they're between 0 and 1. The logarithm is, let's not go to logarithms. After a while, this term wins. It's just the biggest. Which means that your ratio for n and n plus 1, when I get you to do the ratio, it's really slick, because the next term up this thing is small for large n, and it will stay small. The next one up is 1.9 to the power of n plus 1. So when I get you to do the ratio, it cancels out the a. The b and c terms are really small, so they don't matter. And this thing divides through by 1.839 to the power of n. So it doesn't matter what two of your initial numbers, it doesn't matter what your initial numbers were, partly because they're setting b and c, which decay, and partly because they're setting a, which I'm making you divide by. It cancels on that division. The number of times you've done the calculation is n, and so long as it's large enough that we could ignore these terms, then the value of n doesn't matter, because that cancels as well. The division is super sneaky at cancelling out something to do with your initial numbers, and also cancelling out the number of times that you've done the calculation, to just give 1.839. I saw Anders in chat say, this is almost the same talk as you saw last Friday. Where did you see this? Did it do the same numbers? I would like to do this on the internet, but if everybody's seen it, then I'm not doing it. I know I'm doing it on the internet right now. Reason I wanted to show you this. Yes, Larud, you can do this for your regular Fibonacci numbers. Homework, I suppose. Slightly easier, because you'll get a quadratic equation instead of a cubic. You will be very happy about what that is. Yeah. Oh, yeah, sorry, no, I've re-raised your question. Yes. The general fact is you can start your Fibonacci numbers from any two positive whole numbers, and the ratio will always end up at the golden ratio. I think that's nice. And this is like the 3-term version of that. I saw Anders, was it Anders? No, Maxi, sorry. Very specific form of polynomial. Can we always solve this? Sadly, no. Not in terms of radicals anyway. The answer for 3 is humorously mad. For 4, it's even worse. For 5, it doesn't have a neat form at all, sadly. Not the same numbers, but it was giving back. Oh, yeah, sorry. Yeah. Not alright. No, you're telling me about the talk. Talking about Fibonacci sequences. Yes, I prefer this because I've thought about this too much. I think the golden ratio is a little bit overexposed. When you do the Fibonacci version of this, when you do the Fibonacci numbers, you get the quadratic, you get the golden ratio, which should be surprising, but I think lots of people are now coded to think, oh, of course it's the golden ratio, it's always the golden ratio. The reason this one makes you sit up and shout why in chat, thank you Toast Potatoes, is that this is much weirder than the golden ratio. Nobody is using this as the basis of beauty in art, or did you know sunflowers? 19 minus 3 root 33. No, no one. This isn't doing anything else. This sort of feels a bit more bespoke and weird. Yeah. Oh, some people already use the silver ratio to mean. Is it this one? I think some people maybe use, or maybe negative of this. Maybe call that the silver ratio already. So like, that joke's already become mainstream for a different number that's the runner-up. I think it's sometimes called the plastic number, but I'm not certain. I need to do a little bit more research before this goes on. It is, so Toasted Potato, it is supposed to be, and I really want to format it like the ones where Fun Maths Facts, where it's like, take your age, add 1, divide by 20, subtract 1/20th, multiply by 20, subtract the number you first thought of. Now you're back at 0. I know, it doesn't sound, it's not a very cool fact, is it? I think it's that. Oh no, I'm wrong. The plastic constant is something else. It's the root of a different cubic. What's my one called? May need to do more research. Oh, the plastic number looks pretty cool, actually. I'm on the Wikipedia page for plastic number. Aluminium ratio. What do they say on Reddit for like the backup one? Oh no, that's Silver Award, isn't it? What they say on Reddit. But then they made it official, and then they took it away. I don't know, man. Right, how are we doing? 10 to 4. The other reason I wanted to show you this is because this maths is exactly the same as the original maths. Fool's gold ratio, that is perfect. We're having that. That is brilliant. Who said that? Maxi. Good, brilliant. Sold. That is exactly what I want to call it. This is exactly the same maths as the maths we did at the start for the differential equation, right? We started with a problem where you can maybe see some solutions, but not very many, and then there's some general method for converting it to a polynomial, solve the polynomial, and you're done. You get a sort of full picture of the answer. You get this kind of your different parts of your solution which you can combine together. Vigi, is this how uni maths gets taught? Not really. I'm trying to make it more. This is me picking and choosing, right? Uni maths is a healthy, balanced diet where you learn lots of different things that are good for you. You've got to eat your greens. You got to learn a lot of stuff that's not on its own inherently exciting. Whereas for the chill maths stream, I'm just raiding maths for like raiding the fridge in the middle of the night and just choosing all the best bits. Like, ha, ha, ha. So picking up my kind of bits and pieces that I want to show you. Oh, Bazoo. Yeah, this is just like, I'm not telling you any of the reasons why stuff works, even though that's really important. Partly because I can't remember it, partly because I'm not super excited by it, so I can't do it with my exciting voice. Yeah. Potatoes also claims fool's gold, but it's called pyrite. Okay. We put like pyritus. I feel like pyrite could be a good for the pyritic equation or something. You need like an adjective in here somewhere. There you go. The equation that gives you fool's gold. Oh, and it's got fool in it as well. Okay, nobody says pyritic. I may have invented a word. I can't put Munro on it. Munro's not. I expect the next one would be the fourth. So the quartics have a closed form. So I suppose the next one up would be the solution of. I'm doing these in Mathematica, by the way, because I don't actually know the cubic formula. The next one up would be maybe worth having a name. If you add together more terms, so if you homework, if you do a version of this trick where instead of 3, it's like 4 or 5 or 30 or something, and you add them and delete the smallest and keep going, then it always does something nice. And the answer that you get for 2 numbers is the golden ratio. For 3 numbers, it's the Foolscald ratio, which is 1.839. For 4 numbers, it's 1.92. For 30 numbers, it's really, really close to 2. Oh, what was that? I missed an ad. Could I attempt a UKMT SMC one stream? It always has nice solutions. Let's see if I can actually get the paper. I'm not sure I can. Senior Math Challenge, right? Can I get the official papers? View past papers. I'm trying to find out if I can put them on screen. I'm supposed to be doing Bazoo. I said I'd do Bazoo. We might save Bazoo for another day. Bazoo lets you solve amazing things like with, wait for it, M and N whole numbers. It is. I've put a big circle around it like it's important or related to the other stuff, but yeah. Ruth, that's a great question. The answer is no, it's not obvious. It's not obvious why the other routes don't cause problems. I've tried to prove that. I'm working on it. Something that I'd like to work on, I think. Not in the working like this is research maths or something, but just it's something I should check before I make big statements on a number file video, right? Because it kind of feels like one of the routes is big enough that the others have to be quite small. Hi, Finesse is better. Yeah, I've done them 2 Sundays in a row. I don't know. That means that I'm. Oh gosh, I don't know what I'm doing. I clicked on your message and now I don't know what's going on. It was a one-time thing, and then it happened again. So I don't know. I think I enjoy doing these. So if it's oh, I can see the questions. I can get the questions. We can do this. This could happen. People want this. It happened twice. Oh, they've released it. Right. Okay. Let me try and load it. Yeah, I can get it on stream. Would this work? I might want to load it onto the device. So I can get it like this at the moment. It's not a great not great live stream experience. It's too much grey, isn't it? Yeah, the question's but really small. Wait, this is the three circles with radio joining. I love these problems. It's simultaneous equations for the side lengths. And the area, oh, let's hope it's right angled. What are they? So the sides are 5, 5, 6? Huh. Oh, drop a perpendicular and you get 5, 5, 3, 4. It's made of 2 nice triangles stuck together. Good. 5 and 4 is 20. Yeah, cool. Is that an option? No. 3 and 4 is 12. 12. Good. B. Okay. Oh, this is good fun. Yeah. What is going on here? This is a crossword. Why is there a star? Oh my goodness, they've made this a lot more. Oh, they're doing that lie stuff. Yeah, we should probably do some of this on stream. This looks like a fun Sunday activity. Heron's formula on the 556. I guess some people just want to see the SMC burn. That's quite a lot of questions. I don't know what the copyright is, by the way. I mean, it says at the bottom it's copyright UKMT, but I don't know if I'm allowed to show it on my Twitch stream. Possibly if I'm saying things like, these questions are cool. Everyone should get their school interested in the SMC. UKMT stuff's often quite a lot of fun. Put a square in a hexagon. Wait, I want to do that for math. I mean, I can't anymore because I've just gone on the internet and said I want to do it on math. That looks beautiful as a setup. It's a square inside a hexagon. 2 of the edges of the square parallel to 2 of the sides of the hexagon. That's very nice. Hats off, that is good. That is good. Wait, they're getting you to do sine of cos inverse? Oh, senior maths challenge, you know about inverse cos. It doesn't feel very UKMT to me somehow. I mean, it's literally on a UKMT paper. Oh yeah, please don't. Yeah, okay. Yeah, like this. So please don't do the square and a hexagon thing. Right, good, okay. Yeah, good suggestion. Sort of maths I like to do. Who knows, we're going next year, this might become STEP. I don't think I should do a STEP live stream. Oh, gosh. Some of my friends do STEP tuition. I'm not really sure about that. STEP live stream, which is just chill. Vanessa Speller says they've used Heron's formula on the mat. Oh, wow. Vanessa Speller, we try not to... Was it for the... Don't tell me it was for the short question, the multiple choice question with the side lengths. I gotta go at 4 o'clock, but I want to know what's going on there. What's more clean, the solutions for step questions or mat questions? Step questions are just longer. If by clean you mean short, then there's a mat in 10 minutes video. I don't think anyone could do a step in 10 minutes video. That is a challenge. Mat questions often have shorter answers, but step questions have often got like a good idea where if you understand the idea, then you're kind of done. It was for the triangle multiple choice. Oh gosh, no, I want to do that. Hang on. I'm not saying it's bad, just S is like, so you've got 10, 10, and X or something. So S is 20 plus X over 2, which is 10 plus X over 2. And then your Heron's equation, you want to maximize, or you want to extreme values of S, S minus 10, S minus 10, S minus X, which I suppose is just a polynomial in X, so you can go and hit it. So you can go, this is 10 plus X over 2, this is X over 2, this is X over 2, this is 10 minus X over 2. Oh my goodness, this is actually looking like a good idea. Hit it with a factor of 2 to the power of 4 or something, and write it as 20 plus X, 20 minus X, difference 2 squares, X squared. So that's 400 X squared minus X to the 4. Which dpdx, oh my goodness, this is actually a brilliant idea. To finally get down to X squared is like 200. So X equals, so you've kind of proved that it's 10 root 2, and then pick the closest, which is like 15 for X. That is not bad at all. Yeah, I would. Laroud, the thing you've said is the answer that I'm going to put in the. You're going to put in the. I'm going to put in the 10-minute video to just use halfway BSIC. Handwriting. Circles and square. I think it's too minus root 2. I mean, we're doing a 10-minute video that might already be up for all I know, but the circles in a square question. The idea was kind of a joke. It's independent of the ratio of the areas. If you draw in some radii, which you should always do when you've got things that are tangent to other things, right? Draw in the radii if you've got some circles. If you draw these in, then we've got R1, R1, R2, R2, and the width across here is R1 plus R2 over root 2 plus R2, and that's supposed to be equal to 1. But this is like some linear multiple of R1 plus R2, 1 plus 1 over root 2. So then you divide through and you're good. Yeah, the area wasn't relevant, but question design if you want it. If I don't fix the ratio of the areas, then you could, if I tell you that it's independent of the ratio, then you could set one of them, you could set them to be equal to each other and make it slightly more obvious. I decided if I told you it was independent of the area ratio. It's not quite true that it's independent. There are limits on how much you can make the area, because if you make one circle so large that the other one only just fits in the corner, then if it's touching all 4 sides, then that's kind of a limit on the ratio area. So I had to make sure that 10 was literally possible, which is a weird sub-question to do. Often when you're writing a mat question, you have to do like 3 times as much mat question. I have to solve this problem for, what if this one's tangent to all 4 sides and there's a small one? What's the ratio of the areas in that case? Because that's the kind of extreme ratio. It turns out to be independent of the ratio between R1 and R2, but you've got to set it up so that it actually exists. And then when you draw the diagram, you want to draw a diagram that's not to scale. So you have to actually solve it in general. So that you have to choose R1 and R2 and make sure that it... Oh, I just have to work it all out. What's question 2? Question 2 is a vaguely standard bit of... I don't want to say too standard, but question 2 is secretly secretly all about cosine substitutions. I think that's good. I think that's allowed. There's this trick that you often do with complex numbers, where this thing is equal to cos 2 theta, or times 2 or something. So there's this trick where you add together powers of exponentials with the opposite signs up here. It gives you these cosine things. So you can use that to solve equations, sometimes, or to rewrite trigonometric identities. It's just a fun trick. So we took that trick and turned it into powers of x to make it more approachable. Obviously, much more approachable than having any complex numbers around. And used it to see what we could do with it. It's based on, it's not an original idea for how to solve equations, if that makes sense. It's this idea that the idea basically is that you've got this and you try and do a substitution for r e to the I theta, but we don't make you do that in the question anyway. This is a little bit like x plus 1 over x is a pretty good substitution, but that would have a 2 in it, so it's got plus 1 as well. So then you can maybe solve this as a pair of quadratics. Scrap paper didn't get scanned. Root is probably fine. We're going to mark your answers based on your first approximation. We're going to mark based on the ticks in the grid. So we're going to give you the marks there. It would be nice if tutors had access to your working out in case they want to look at it, but it's not the end of the day. How many roots there were for the A's and B's? That's in the 10-minute video, but let's have a go at it now. I think it was these ones. So if these have got repeated roots, that means that b squared minus 4ac is 0, and c squared minus 4ab is 0. And then the thing we want to know about a squared minus 4bc. We want to know, is it positive, is it negative, is it 0? So we should try and calculate it. The fastest way to calculate it, I think, is to write these as b squared equals 4ac and c squared equals 4ab, and multiply both sides to get b squared c squared equals 16 a squared b c squared. Have I done that right? I'm not sure I've done that right. a squared bc, just a squared bc, which then gives you bc is equal to 4a, because I reckon we told you that stuff was positive or non-zero or something, which you can now plug in to say that this thing over here is minus 63a squared, which is negative. If it's negative, there are no roots for the other one. Did we give up on probabilities in multiple choice? I don't think I did any this year. We did any this year. Don't know if the vectors question was a bit weird. Wouldn't say they've gone away forever. Yeah, no, you shouldn't. When I said de-anonymized, I was joking. I think we got you to write your candidate number at the top of every page. So it's not that anonymous, right? We technically don't know your candidate number and linking up to the people. The people market, the team of markers definitely don't know. Maybe that's the reassuring thing. Don't worry about it. There was enough chaos anyway, right? I doubt anybody's written their candidate number at the top of the pages. The plan there was, if your teacher's scanning it and drops it, then they know which one's which. But to be honest, at this point, if your teacher scanned it and dropped it, then they say, and another thing went wrong, and it's just another special consideration on the pile. You could put, there was a bit on the top of the answer sheet to write your candidate number on each page, but we didn't really brief you on this. If you're the only one who took it in your school, then we will definitely be able to work out whose it is if it doesn't have any numbers on. But you probably put your name on the front page and stuff, so, you know. And also, you're the only person from A, but it's going to be fine. It's my problem, not yours. There we go. 2023 felt a lot worse than other years. Yeah, I feel like we're now turning into a Matt live stream, which, oh well. Sorry. Constant D. I can't remember what D was. Sorry. I'll look at it when I'll get my marking team to look at it when we get there. Oh, sorry, Maxi. People have done a maths test for me, and for Oxford in general. For me, it's a really weird way of shortening that. Finesse, sorry that you spent lots of time writing on every page. I think most people did, to be honest. Hi Neo, the one. Oh, we got new chat people. My viewership's gone up again at 4 p.m. I'm trying not to talk about Matt. There's an official department statement that's going to get released at some point. We know that things went wrong. We want to make a plan to make things right. We are going to look at all the information first. For English, I know the English department have put out a statement already saying what they're going to do. The maths situation is slightly different, so we're taking a little bit longer. Sorry that we're slow. From our point of view behind the scenes, we've got at least a month until we make any shortlisting decisions anyway, so we've got quite a bit of time before the next step. A new map, which is just question 6. Question 6 had the advantage of being about an actual thing that, you know, it is actually a nice thing that you can do. I believe they're called proof of codes. The thing to Google. If you would like to see that ever again, and it sounds like you enjoyed looking at it. So if you want to look it up, then there's some maths out there. So Neo is the one. Neo is the 1-1. Neo the 1-1. I can't comment yet on whether the maths decision will be the same or similar as the English decision. I'm trying to warn people that the departments are separate and make separate decisions based on the particular circumstances. The English test had a second problem that means that even if it hadn't been disrupted, there was a mistake in a question that was quite bad. Not that that would ever happen in math. Yes, I'm not saying too much. Also because this is my unprofessional separate stream that's supposed to be me doing maths that I like. Like, hey, we just invented a fool's gold ratio. It's pretty cool. Yeah. So if we just let's not do it out loud, but yeah, I think any solution is going to make some people happy and some people sad. We're trying to work out the right combination solution, if that makes sense. Try and minimise how sad everyone is. Right, good. Okay, I've gained some followers and some actual subscribers, which is very exciting to me. I'm learning more and more about Twitch every day. I think my homework is to try and find out how Twitch emotes work. I would like some custom emotes. We're going to try and do that. Thanks, Kimchi, for the positive words, even though stressy. And thanks for the follow, Neo the 1-1. Maybe in a week or two, once the department has made an announcement and we've got more clarity, I can talk a bit more. But I think I'm also doing some official streams. For those who don't know, I do unofficial streams under my own name on Twitch, and I do official streams under the Oxford Maths account on YouTube. I try to keep them quite separate when I can. This weekend has not been good for the separation of work and home life. This weekend has been quite bad for the overlap between my two characters. But in general, going forwards, if you subscribe to this channel, we are trying to do chill maths that is not related to university admissions. Just interesting bits of maths that I've seen through the week or remembered that I want to show you. I'm going to try and be live each Sunday, unless I'm doing something else. But it's professional live streams, occasionally on Thursdays on the Oxford Maths Plus channel, unprofessional live streams on Sundays, irregularly on the James Monroe channel. iToastPotato's got 950 channel points. I don't know what they are. Hello, Elante. Oh, thanks for the follow. This is call to action. Look, if you follow, you will get X. I've got to work out what channel points are because Toast Potatoes has got some, and there's no emotes at the moment. Do you have to spend them? Oh, there's a link. Wait, did you spend money on that? Actually, on my screen it says redeems highlight my message 100 circles. Not money. Okay. Channel points are free. Okay. Oh, and it's not a link. It's just your chat message just looks better. Not on there, but from, just time. The one currency that cannot be refunded. Time of watching the stream gets you channel points, which lets you use a highlighter in chat. Okay. Oh, and it's like, I can't pin it because it's already high. Oh, right, good. Right, okay, everyone's spending those points now. It doesn't work up there, right? It only works... Do you have to be a sub to get them, or do you... No, Maxie's not subscribed. You don't have to give Prime anything. I'm trying to be helpful afterwards as well, right? Everyone can get channel points. Right, do I get channel points? I've got infinitely many channel points. It's got a little infinity symbol. Can I highlight all of my chat messages? Oh, I have like a login process I don't understand. So I can create custom things to spend them on. So do you have to spend them on... If I make an emote, do you just get to use it, or do you spend channel points to get it? Because what I'd like to do is design some stupid channel emotes that are like mathsy. I've got some ideas, but I don't want to put them behind like a pay barrier where you have to do money for it. Doesn't feel right. Is it countably infinite? Yeah, I can only spend finitely many at a time. And the time... I guess... The thing to do would be to try redeeming... twice as many... So to try redeeming them more and more frequently, faster and faster and faster point redemptions for staff, with redeeming more and more of them each time to try and get it to converge to a higher... Anyway, subs get to use it always. If you include the option, we can spend channel points for 1 day of emotes. I mean, that sounds sort of okay, right? Okay. My plan is, I want... You can help me design. Get involved, chat. I think I've got 5 slots. One of them's animated. The animated one absolutely has to be droplet coalescence. I'm sorry. It was 4 years of my life. You're getting a droplet coalescence emoji. Nobody wants a droplet coalescence emoji, but it's going to be animated like this. I don't know what it means. I don't know what context you would use a droplet coalescence emoji, but I see animated. I know what to do. I think you maybe want some sort of like official like heart symbol that's maybe mathsy somehow. Maybe it says maths on it. I think you maybe want like a choice of colours that are maybe for humorous reasons, like Oxford blue and Cambridge blue or something. These are my emote ideas. The wow emoji has got to be one. That's the only reason I activated the affiliate program, so that I could set the wow emoji to be a thing. Yeah. Oh, I want to do so for the animated one. Sorry, I've got this pet project because I've got a really good animation on my website. I want to build it with like Mathematica and stuff. I'm on it. Don't worry. Wait. Rude is doing... Animation is your job? Yes, you got paid for it. You told me once. You're like professional. Australian dollars or something. I remember. Can I post that in here? Yes! It's beautiful! It's beautiful. Let me show you. So, Elrouge gave me some chatting code in chat, and like an absolute idiot, I've pasted it straight into my browser, and it's come back as this heart. I'm just asking for trouble. Yeah. That's perfect. Look at that. That's lovely. That's not too complicated. It's just gorgeous. Why is it 2 things multiplied to give 0? Oh, it's the top and the bottom. Ooh. Oh, that's very good. Oh, I like that a lot. This is brill. That's a very good heart shape, and it's not too complicated at all. Can I do y squared here? Or is that going to give it a... Oh, that's going to give it an up and down. Right, yeah, you don't want that. That's why you put the square root in. Cool, right, good. Okay. And back. Good, thank you, chat. You got US dollars in the end. Stretch the axis to make it look better. Yeah, okay. Oh, I haven't gone back. Game design concept. Money. Oh, the square roots help. Yeah, remove half of it or something. Okay. So, use Mathsy heart. I can't remember who. Maybe LaRue. Someone told me during the live stream. Quintic project, we've got to have that. Maybe there should be a Quintic, or maybe there should be like a. I quite like the WoW emoji. I've got a couple of slots. Suggestions from chat. Oh, I've gone long. This is past 4. But yeah, I think I've got like 5. I don't really understand. There's like 5 plus an animated one or something. This is the. Maybe I should get Toast Potatoes to do this. Hang on, professional animator in chat. Good, and we got 2 that we will work out at some point later on. Plus, like premium, I can't remember. There's like tiers. There's like tier 1, 2, and 3. But I think Prime just gets you this one. So I'm like not very interested in these ones. If you have to give actual money, then I'm not really in it. Log, but an actual log. Oh, there's a log. No, that's they gotta be square, so that's too wide, right? But log, but an actual log. The special dice from my personal statement. I found you can buy them on Math Gear, so not without redoing my personal statement. There are these dice. They're really good. They have weird numbers on. This one in particular has an 8 on it. This one has 3 on it twice. But when you roll them, the distribution of the sum is the same as for normal dice. The odds that you get 7's the most likely, 12 is 1 in 36, actually because you have to roll 8 and 4 to get 12. So that's kind of the same. You've got to get the biggest number on the die, and it's unique. The chance of getting snake eyes is still 1 in 36, 1 in 1. And the chance that you get 4 is like what it should be. So it's kind of nice. The sum works out, even though the dice are super weird. That's going to be I'm pitching that to Brady as a... The maths is a little bit complicated, but I'm pitching that as a number file video. Yeah, we should maybe put some dice in. Do you like some dice? No one's going to appreciate the die with an 8 on it. Die with an 8 on it. Wait, hang on, it's weird for you. I've now got used to the idea that people know what's in my personal statement. Oh dear. Yeah, not certain I want to go all the way into convolution so much as I see it as kind of factorising polynomials as a way of... But then there's multiple ways to do it, and it's not obvious, and I haven't found anything good in the literature for why you can... Sometimes it doesn't work. Grant's too cool for me, right? Well, we'll get there. Grant's doing essentially what I want to do, which is making interesting maths videos for the kind of same target audience that I'm interested in. Except Grant is actually good at everything. It's incredible. 3 Blue 1 Brown is just astonishing. The guy's really good at animation, explaining, maths. He's really good at all of the things. I've got one that's like, wow emoji. Well, yeah. Grant doesn't have a Twitch. We'll get there. Good, okay. It's not the personal statements are not anonymous. That would be fun. I feel really bad I've started a thing now. Partly the joke is that I know Toast Potatoes. Toast Potatoes, I think you emailed me at one point, so I've managed to link. I've de-anonymized you based on you emailed me once with your... It was a very professional email that you sent to a university, but it had your username as I Toast Potatoes, which was I enjoyed a lot. Good, that's the joke. Are we having fun? I think we're having fun. We've got a slot left, which is maybe the logarithms. Dice and logarithms. I can't imagine using any of these, right? I mean, wow, just about. You put the wow down. And the maths love is like, some maths has happened and I love it. Which is kind of the same as wow. But hey, let's have 3 wow emotes. So 3 wow emotes. Then the dice, I think, need to be... I kind of want like an oh no emoji. Or like an ooh. Then maybe dice could be risky or something. Yeah, so it says risky. It looks like dice. You look a bit closer. One of them's got 8 dots. That'll do. Wow. When it all comes together. I like that. Plus, does Twitch has like basic emotes in it, right? Which I feel like I could co-op. Oh no, you're not allowed to base your emotes on the frequently used ones. I tell you, there's something in the way that there's something here. For another time, like homework, emote homework, there exists a Kappa emote, which is like is a famous Twitch emote, which has the same name as a Greek letter that's used in maths quite a lot. There's got to be something we can do with this, chat, right? Right. Venn diagram is like Twitch emotes, maths. And like, the Venn diagram already overlaps. Kappa is already in both. We got to do something with that. Need a confused one. You need to like it. Yeah. Okay. Good. It wasn't that bad. If there exists an element in the set, Twitch emotes and Greek letters. Yeah, math symbols. Homework. What other Twitch emote? I've got to learn Twitch, haven't I? So like the purple heart is like basically what we're doing over here. The standard purple heart. I don't think I'm doing. No, the others I don't really. Oh, you're allowed to do a version of. There's only 2 that you're allowed to remix. You're allowed to remix Kappa and Vohai-Yo, but I don't understand Vohai-Yo. I need a Twitch expert up in here. Right, cool. Unprofessional live streams. I've enjoyed watching the number of live viewers just go, oh, he's talking about Matt. He's talking about somehow people know he's talking about Matt. Oh, he's stopped. Oh, he's talking about Matt again. He's talking about Matt. We're done. People in chat showing me emotes. Yeah. So I know the second one. I don't really understand what the first one's for. Is it a shrug? Is it a shrug? But with like a spanner? I don't understand Twitch. Cool, right. I could probably explain Bazoo instead of doing Twitch emotes. Doritos chip. Oh, the Give Plus has got to be it. First one might be a Twitch developer, right? Okay, I need to learn my Twitch lore if we're gonna go deep on the live stream stuff. Then we gotta learn the background. What have we done today? A lot of stuff today. What have we done today? We've done differential equations. Done. Completed it, mate. We've done Fibonacci numbers briefly, and with a third term in there. The 1.839 number. We've done a little bit of Markov chains, and we've talked a lot of nonsense about maths. That's not bad for a live stream, I think. Not bad for a live stream. I think I'm going to call it there. Everyone enjoy the rest of your weekend. What's left of Sunday afternoon in UK time. It's a lovely, lovely sunny day where I am. I think you are the biggest. I think you are. Finesse is better. I think you are part of the biggest maths audience on Twitch right now. Not all time, but right now I think. There are other maths live streamers, but they don't have these dice. So that's supposed to be a riff on a old loading ready run line, but nobody knows. No, okay, stop crossing the streams. Right, good. see you. I think probably next week. Probably depends how all the chaos is going. Bye. Thanks for the follow. The button didn't do what I thought it would do. Oh, we're going to hit it. There we go. Just like we drew it up.